because that's when the exam is supposed to be taken. And you're if somebody decides they're not going to take money and they just don't show up, that doesn't count as not telling me. And so, all right, I don't need a regular marker. So we started this problem the other day in class. The question was to find the second derivative. So we hurried through some work and we found that the first derivative was this sucker right there. And so then we needed to plug that into our definition of the derivative. So here I have my f of x plus h. Here I have my f of x dividing by h, and let the limit as h goes to 0. And we just need to be really careful with our algebra to do this. So I'm going to break it down one step at a time like I usually do with this version. F of x plus h is that underlined part there. So cleaning that up, I have -6 times that thing squared, which is going to be x squared plus 2hx plus h squared plus 6. Distributing that -6. I get that, and there are no like terms. So that's f of x plus h. I next need to proceed to subtracting that sucker right there for step 2. Again, this was step 1, and color for step 2. And rather than rewrite a bunch of stuff, I'm just going to write that stuff underneath. Keep in mind here, I'm subtracting, so I'm going to treat subtraction as adding the opposite. So the opposite of -6x squared is +6x squared, and the opposite of 6 is -6. Winding up like terms, I think the numerator is now -12hx minus 6h squared. So that's my simplified numerator. Step 3, I get to divide that sucker by h. So 3 -12hx, what is it, minus 6h squared, all over h. Multiple ways to think about that. Factor out the h perhaps. But oh, I can factor out more, can I? I can factor out a -6h, couldn't I? From the numerator? Yeah. So that's going to leave me with a 2x plus h. Looks right. Divided by h. Remember, you can only cancel stuff that's connected by multiplication. So this h right here can't touch that one. That violates the order of operations. But since this h is connected on both sides by multiplication, I do have a number divided by itself, and a number divided by itself is 1. That's why shit cancels, because the number divided by itself is 1. So I now have -6 times 2x plus h. Last step in this chain of events is to let h approach 0, take that limit. So step 4, we take the limit as h goes to 0 of that stuff, and we get -12x.
Yeah, well, I have a question here.
Yeah.
What was the point of factoring out the -6 to begin with? Like, you're going to end up with the same answer anyway, so.
Because when I went to school in algebra class, they beat it into my head that I'm always supposed to factor completely. And so it's like, you know, I wake up every morning and brush my teeth. If I see something that's factorable, I factor it completely. But you're right, I could have just factored the h out. Yeah, totally. Yeah, and any complicated algebra problem, there's always going to be multiple ways to attack it. So yes, I factored out more than I had to. I could have just factored out the h. I could have done it a third way.
Okay.
Yeah.
So you can only take the h out when it's on both sides multiplication?
Like
if it was like 6.
This h right here?
Yeah.
As long as that object, whatever it is connected by multiplication. Right. So this h right here is being multiplied, it's being multiplied, Right? That's its connection to the
Okay,
numerator.
but what if it was -6h plus something? Could you still take that h
If
out?
there was a plus next to the h, it is not connected by multiplication anymore to the whole numerator, so you can't touch it. All right, I think we found the second derivative, so I would call this f double prime of x. And somebody had written a note in response to Peter yesterday about applying a special rule called the power or exponent rule. That we will cover later in chapter 3. So although it is a very excellent answer, it's an answer to a different question than this one. So responding that way on the test, you wouldn't get any credit because you didn't apply the limit definition. And I put a note in that in the forum. I don't know if anyone saw that.
You should.
Yeah, so if it says use the limit definition, you gotta use the limit definition. You can't use any shortcuts that you might have seen in the past life. All right, let's do another one. Question.
Do you have one in mind, or are you open for questions?
I'm open for questions.
I wanted you do a question like that, but with the alternate definition, because I ran into problems.
So do a quadratic with the alternate definition?
Mhm.
Yeah, we'll do that one right there. So let's go back here and grab that problem. So I'm just gonna take this one, and I'm just gonna do the first derivative, if that's okay. Copy and paste. So I'm gonna apply the alternate definition here. If you don't like the alternate definition, then feel free to tune me out for 5 minutes. So limit as b goes to x of f of b minus f of x over b minus x is one way to write that. And with this one, there's not really a 4-step process. It's just different. So I get the limit as b goes to x, and I start figuring out what is f of b. Well, that's not too bad. It is negative 2b cubed plus 6b plus 2. Careful here, subtract, put parentheses because it's complicated, and then plug in your x version. All over b minus x. So again, I was exercising care because this whole piece of stuff has to get subtracted one chunk at a time. And then I can reorder that perhaps. Maybe I'll write it as negative 2b cubed plus 2x cubed. Put terms that are similar in power together. 6b minus 6x. And 2 minus 2 goes away. That's kind of nice. All over b minus x. And if I try to cheat here and evaluate the limit, letting b go to x, replace all the b's with x's, I'm going to get 0 over 0, which is a problem. So now I'm praying that somehow this is a factor of all of that. Right, so now we got to mess around with that numerator. So let's see. I'm going to reorder things again as 3x cubed minus, is that a 3? And I get that right? 2, oops. 2x cubed. So then we just hope we can pull out some clever algebra. What was next? 6b minus 6x. Anybody recognize anything here? It's the difference of 2 cubes if I take the 2 out. Yeah, so if I view that as 2 times x cubed minus b cubed, then the x cubed minus b cubed factors as x minus b. Remember we went over this formula a couple of days ago, I think. Or was it yesterday?
Yesterday.
Okay. Times x squared plus bx plus b squared. So that factor, that's cool. This next part, I can pull out a 6, can't I? So I have a plus 6 times b minus x. Ooh, that's interesting. So I have a sum in the middle, right? And then on one side of the sum, I have a factor of x minus b. On the other side, I have a factor of b minus x. How are x minus b and b minus x related to each other? They're opposites, right? Yeah, so one's the opposite of the other. So I'm going to factor out, let's see, what does the denominator look like? It is a b minus x. So I'm going to factor out a b minus x from this thing. So from this term right there, if I pull out a b minus x, I took a b minus x, which is the opposite of that, so I'm going to end up with a negative 2 times x squared plus bx plus b squared. Over here, I'm pulling out the b minus x, so I just get a plus 6. So have I succeeded in factoring out a b minus x? The answer is yes. So that's going to cancel with my denominator. So if I throw my denominator back in here, since this b minus x is connected to the whole numerator by multiplication, what do I get to do?
Cancel.
Yeah, I have a number divided by itself, which is 1. Multiplying by 1 is kind of boring. So what's left is this stuff right here. And can I take the limit now as b goes to x? Yeah, I can. So let's see, new page. If I do that, I'm going to have a negative 2 times x squared, and then b goes to x here. So I'm going to get another x squared, and then b goes to x. What do I get?
X squared.
Yet another x squared, and then I have a plus 6 just chilling on the edge. So it looks like, how many x squareds do I have?
3.
3 of them times negative 2 gives me
Negative 6.
negative 6x squared plus 6. Is that the right answer that we came up with last time?
I think so.
Yep, same answer, different way. Was that any easier?
No.
I don't know about that time. I think it was about the same. Okay. So I mentioned that before. Sometimes the alternate definition is easier, sometimes it's harder, sometimes they're about equal. You never know until you try both ways. All right, moving on. Somebody had a question about a square root problem. Was it 3-2 or 3-1?
Is it the square root one?
Ms. Miller, did you have a question?
No, they're big. I got
You got it? Okay. Does anyone else have a homework question, or I'm going to move on?
it. Wait.
The review, number 12.
Review number 12. What's up?
Nothing.
You did not say what I think you just said.
Yeah, I did.
Sarah.
I know here.
Review or the sample? The review, right then?
Yes.
Okay. Review number 12.
Oh, ew.
How many problems are on the review?
A lot.
There's 44.
44,
And then there's 25 on the physical one, correct?
Yeah. something like that. All right, so we're given this particular function, and we want to know if there's any holes or vertical asymptotes. Both are related to limits. So this is a limit question, essentially. Screenshot it. So just a reminder about these kinds of things. If you take a limit, let's say x goes to a, and you have something like, if you end up with something like 0 over 0, that's a candidate for a hole in the function. Candidate, spell that right?
Yeah.
For a hole. That's the right version. Hole, yep. Yeah. But I don't know if it's a hole until I check. It's a hole if it's undefined and the limit does the same thing on each side. Okay, so that's the other thing we have to check there. If you have something like the limit as x approaches a of f of x, and let's say we're approaching on the left or the right side, and you get an infinity growing forever, or maybe dropping forever, then this would be a very classic code. So those are the things we're looking for here. So to figure that out, I need to factor this thing first. So f of x in factored form. Let's see, 28 factors as 4 times 7. Okay, so that's not too bad. So this is x plus 7 times x minus 4. 63 factors as 9 times 7. 9 plus 7 is 16. Man, I'm on a roll. So this would be x plus 7 times x plus 9. So if x were -7, what's going to happen?
All
Yeah, so if x is -7, then f of x is 0 over 0, which at first glance is undefined. But if I remove that factor by saying a number divided by itself is 1, and I take the limit, then I'm actually going to get something out of that. So the limit as x approaches -7 of x plus 7 times x minus 4 over x plus 7 times x plus 9, that's equal to the limit as x goes to -7 of just x minus 4 over x plus 9. And since the 7 is no longer a problem with zeros, then what do we get here? -11 halves. Is that right? So I should find that if I graph this function, it looks like y is heading to -5.5 when I go to -7 on either side. What should I do next to confirm that? Graph that sucker, right? You guys got these awesome, powerful calculators. Use them. So Desmos f of x equals, I'm going to do the original version, which was x squared, I think, minus 3x plus 28 divided by x squared plus 16x plus 63. I think I got that right. And then -7 is the troublesome value. This doesn't look right. Did I get that wrong? Plus minus. Oh, I did type it wrong. Got these signs backwards. Plus minus. And that looks about -5.5. So at 7, it's undefined, but near it, it's pretty close to 5.5, -5.5. So I found a hole, right? All right, so got that. Next part, what other number is going to be troublesome for this function? -9 is going to be trouble for this function. So, oops. If we take the limit as x approaches -9 of x plus 7 x minus 4 over x plus 7 times, what do we have? X plus 9. Again, this is kind of, I can get rid of that. It'll behave the same way. I'm going to have a slight problem. If I'm to the left of -9, so if this was something like -10 for x, I'm going to have a negative denominator and a negative numerator.
Positive.
However, if I pick an x on the other side, if x is greater than, so this is x is less than -9. If x is greater than -9, like -8, then I'm going to have a positive in the bottom and a negative in the top. I'm going to get a negative answer. So can you see I do have to approach this from both sides? Okay. So just by doing that sign analysis, here's my belief. And we'll look at the graph to confirm, and we can check some numbers. If I'm on the left side, then I'm going to get a negative over a negative, which makes me believe that f of x is going to be heading to positive infinity. If I, however, am on the right side of negative 9, what's going to happen? According to the sign analysis, what kind of number am I going to get? Positive or negative? If I'm on the other side. I'm going to get a negative number. So on the right side, it should be approaching negative infinity. So if I draw a line at x equals negative 9, I should see that on the right side it's dropping, and on the left side it's rising toward that vertical line. And we can plug in numbers to check that out. We should look at the graphing calculator. So I'm going to zoom out, graph x equals negative 9, so I can see that boundary there, and then just zoom out. Yeah, it's behaving just like I thought.
So the whole is -7. And the
So yeah, so back here, the whole here would be x equals -7, and the vertical asymptote happens at x equals -9. Yeah, so if this were a test question, it wouldn't be sufficient just to state that. I would need some work to go with it, which would be a sketch of the graph, some limits, maybe a table, something like that. All right, other things you all want to do. Yes, sir. Which one?
23.
23. Beautiful. All right. So f of x is a function which is continuous everywhere. So we have to find a value for b that makes that happen. Page, screenshot. So just want to emphasize, I don't know that number yet. I need to figure out what it's going to be so these two sides meet. So I got to figure out what the other side is doing. So if x is 7, I want to know what is the top part, 8 times 7 minus 6. That's what, 56 minus 6, is that 50? I get that right? Yeah, so this says, if x is 7, the top part says y should be 50. So now I just need the bottom part to match. So I need -5. What x value am I concerned about here? 7 plus b, I need that to equal 50. So if I can find b that makes that work, I'm great. So let's see, what's that? -35 plus b equals 50. Add 35 to both sides. And b seems to be 85. Am I done? No, I don't know if it's right. I gotta check it out. So either you need to graph this by hand or graph this with a calculator, figure out if this line and that line meet each other when x equals 7. Or no. So let's see. I'm going to use a calculator because I have one handy here. And if using the limit note, the piecewise notation in Desmos freaks you out, then don't use it. Just plug in the two lines just as they are. You could just say y is, what's the first one again? 8x minus 6, 8x minus 6. And the other one, I believe now, is y equals -5x plus 85. Is that what we just determined?
Yeah.
Okay. And then where do I want to check this out at? I want to check it out at x equals 7. So now I just got to find, let's see, where's that going to be? Way down here, maybe? X equals -7.
It's -7.
50 or the
So it's x equals 7. Oh, I'm on the wrong side. Oh, shit. Sorry. Ah! Oh, I got -7 stuck in my head. And, oh, yeah, looks like they meet there. So I did it right. That's not what the function looks like, though, right? Because one piece doesn't exist on one side of the line, the other piece doesn't exist on the other. So let's see. This one exists if x is less than. So the green one exists up to that point, and then the purple one takes over. So this function should have a V shape, and those top pieces don't exist. If you're dying to do it with the other notation, reminder how that works, y equals curly bracket, and then you take the condition, x is less than or equal to, oh shit, it's not less than or equal to 7, and then what is it, colon? Sound right?
Yeah.
And this one was 8x minus 6. And it goes right up to there. And then I do a comma, the other condition, x is greater than 7, colon, negative 5x plus 85. Hey, look at that, ba-bang. Nice. Okay, so a couple ways you can check that. All right, next, what do we do?
On the printable version.
Yep.
Under the no calculator section.
Yep.
Just the first question, the limit of percent.
Yeah, so interpretation of that. So I'm playing with limits, so just in general, limit as x goes to some number a of some function f of x, I'm hoping there's some limit L, right? Here, the particular problem says, what's the limit as x goes to 2 of 3?
Yeah.
Since there's no.
Yeah, so I would interpret that as y equals 3, which is graphically 1, 2, 3, a horizontal line
Great.
at y equals 3. So no matter what x is doing, what is y here?
0.
3. Y is 3, no matter what. Yeah, so if x is 1, y is 3. If x is 2, y is 3. If x is 3, y is 3. So as x approaches 2, y is just stuck traveling that horizontal line.
Alright.
So the answer is just 3.
Okay.
So could you interpret that since there's no x value connected to it, that no matter what, it would be that value?
Yeah, since there's no x in the expression, it's just that thing. So a similar question, if I said, what's the limit as x goes to 2 of b? The answer would be? B. Whatever b is, oh, it's b. Because there's no x's there. Yeah. So some of these, like there's no work to show, either you know it or you don't. So for example, question number 1 is one of those, either you know that rule or you don't. Question 2 is the same way, either you know that limit or you don't. The ones after that, you'll have to show me a little bit of work, because I could kind of do 3 in my head, but I wouldn't recommend that on a test.
Number
All right.
4 there. How did
Number-
you write that out?
Number 4, how would I approach that one?
Yeah, for writing it out, I can really.
Yeah, so let me grab that into my screen. Shots. So this says x is approaching from the right. And a couple of ways to do this is, one, you could make a table. Pick some x values on the right side, so 0.1, 0.01, 0.001, and see what happens.
We don't have a calculator, so I was just wondering how we.
You can do that without a calculator. I have faith in your arithmetic abilities. So that would be 1 over 0.1,
Just write the fraction there.
100.
which is 1 over 1/10. How do you divide fractions? You multiply by the reciprocal. So that's 1 times 10 over 1, which is 10.
Oh, no.
Yeah, if it makes you feel better, use fractions instead of decimals. What happens if I plug in 100th here? Then I get 1 over 100th, which is really 100.
Okay.
Oh my goodness.
So do I expect you to do math without a calculator? Absolutely, I do.
If the 1 is in the 10th place, no, never mind. That does not work how I
So we
thought it
just
would.
flip it around the decimal since 1.
Just flip around the number
So
on the
if
decimal.
reading this, that's the tens, hundredths, that is 100th.
So just ignore the decimal because then it's 100.
Just ignore
So
the
this is
decimal.
Yeah.
100, this is
Oh
tens,
my
hundreds,
goodness.
thousands, this is 1,000.
That's
Yes, I
what's
expect you guys to know place value and fraction arithmetic.
Oh, goodness.
Alternative
That's
is
okay.
you would have to graph this thing. And how do you graph a function? You plot enough points till you see the pattern. right? So I could plot the point 1, 1, then what do? I could plug in 2 and I get 1/2. I could plug in 3 and get 1/3. But that's going the wrong direction. I need to go this way, so what x value might I plug in next?
0.5.
Or I prefer it as 1/2, because what happens when you flip 1/2?
2.
You get 2. And then what other x value might I plug in?
1.4.
So there's no way to do this problem without making table values. Okay? Yeah. Good question. I'm glad you asked that. Because I do expect some evidence as to why you think the answer is. You can't just, so if you just write infinity here and there's no work, I'm not going to give you full credit. Okay? Do I expect you to know that? Yeah, I expect you to know it, but on this test, I want you to write me some evidence. All right, what else should we do?
Can you do the first question on the review? Just let me see.
First question on the review.
It's the old one, it's the.
This one right here?
Yeah.
The whole moon. I'm not going to do the whole thing, but I'll do
Just do, like,
some
one.
of it.
Or 1 or 2.
Yeah, so maybe I'll do this one right here.
Okay.
All right,
I just
so
need to watch it again.
new
Too
page.
long.
Yeah, so this is a secant line problem. So we've got, what's that?
To what extent are we allowed to use Desmos? Because for this one, I could do like Desmos pretty easily.
You can use Desmos on anything after the first page.
Okay.
Yeah, so the way the test works is
Right.
when you show up to take the test, you get page 1 only. When you're done with page 1, you turn it in, and I give you page 2, or the test proctor gives you page 2, and then you can take out your calculator and start working on the second part. You don't get both parts at once.
Do we have to have a calculator or can we use our phone?
The instructions I gave the testing center is you can use Desmos on a device as long as that device is in airplane mode, which means it can't be
Which means
connected
the
to the
testing
internet.
center is going to be pull Desmos up on the.
You have to pull it up first and then turn off and show them that you're not in Wi-Fi mode or cell phone mode or whatever. Yeah. So if it's a laptop, you have to turn off your Wi-Fi after you open Desmos. If it's a cell phone, you have to put it in airplane mode after you open Desmos, and Desmos will work fine that way. All right, so 4 to 4.5 is the interval. So the question, part of the question here is to find the secant slope on the interval, and I don't know which one I picked. Maybe it was 4 to 4.1. The options.
Yeah.
Yeah, 4 to 4.1. Okay. So again, secant slope is just change in y over change in x. So I have to find the value of h at 4.1. Then I'm going to subtract the value of this function at 4 and divide by the difference of those two, 4.1 minus 4.
Okay.
So now I just got to whip out my calculator and make those calculations. So if at this point you will, if this question's on the test, you will have Desmos for this one here. So on Desmos, the way I would do it is I would just enter that as h of x equals, I can't remember what it was now, 33 minus 8.3. 33x minus 0.83x squared. You got to use x's instead of t's here. It does something different for t's. And then you could just, pretty much type that expression, fraction h of 4.1, h of 4 divided by 0.1, and it says it should be around 26.277, should be the slope in that region. So if you use a calculator, I'd like to know what you told the calculator. So at this point, let's see where they get there again, 26.277. I wrote what I told the calculator, right? And so next I'm just going to say, hey, it's,
Just write that part right there.
what's that?
Just write the difference.
Yeah, this is what I told the calculator. It's on my paper, and now I just write whatever the calculator told me, which I forgot again.
26 point something.
477, I think. So try to remember that anytime you use a calculator, write down what you told the calculator to do, right? Not too bad. Just keep track of your work. So that way, when I look at it later, I can see what you were thinking. Or if it doesn't go well, when I give it back to you, we can kind of figure it out. Because everyone's going to have to troubleshoot their test after they take it. All right, next, I'm dying to do precise definition of the limit.
Yeah. Yes.
Yeah, let's do one of these. So Peter wrote about which one, number 16, the other day. So I think I'll do 17. Page. So the first thing I'm going to do is I'm going to write down the precise definition of the limit. It's kind of hard to read. Let's make it bigger. Oh, easy there. All right, so the precise definition of a limit goes like this. First, you have to have a limit. So limit as x approaches a of f of x equals L. If you have a limit, then what it says is for all numbers called epsilon that are positive, there exists some delta that's also positive such that if the distance in the y values is smaller than epsilon, then the distance between the x values has to be less than delta. That's one version of it. It's the version I've been presenting. So again, what we do here is we start with that. So that's where we start. And we try to make that look like this line down there. So I just plug in my given information here. So in this case, I'm going to have the limit as x goes to 4 of 1/2 x plus 1. Let's see, if we plug in 4 there, we get 3. Is that right? So there's my L. So I won't necessarily give you L. You might have to find that. All right, so then I plug that into here. So what's that give me? Absolute value of 1/2 x plus 1 minus 3. Absolute value closes. That's less than. In this case, I just give you epsilon instead of a number. And then we have to play with this. A couple ways to attack it. I'm going to leave the absolute value there. I find that usually the easiest way to proceed, depending on the problem. Sometimes we have to split into 2 inequalities.
Do we want it to look like x minus?
Yeah, so the x minus a, so for us, that's going to be x minus 4 is what I need to get this to look like. Oh, that's the goal. So here, I got like terms, so that's 1/2 x minus 2. I need the 1/2 to go away.
Slice of 2.
Yeah, multiply everything by 2. This 2 gets to distribute. Now, it is safe to distribute the 2 through because it is positive. I can bring it into the absolute value there. So 2 times 1/2 is 1. 1 times x is x. Minus 4. Oh, we did it. It's less than 2 epsilon. What should delta be here?
2
2 epsilon. Yeah, that's it. I'm done. Boom. Delta could be smaller than that, but that's the biggest delta could be. Yeah. Questions?
So the question on the printout one that
Uh-huh.
says state the precise definition of a limit, is it the whole for all?
Yeah, so if I ask you to state the precise definition of the limit, then you would state this blue stuff.
Do we have to write it out ourselves? Like for all epsilon is greater than.
You would have to write that out, yeah, just like that.
Oh, gosh.
So what I'd recommend is writing it on a poster board and sticking it to your ceiling above your bed so you can lay there and stare at it before you fall asleep. Burn it into your eyes.
I think that would only work for you, Gary.
I used to hang up formulas for math classes on the headboard of my bed, and I look at that before I went to sleep. I did used to do something like that. Okay, let's do another one. What should we do?
How about number 15 on the review?
15 on the review. Beautiful. Let's do it. Okay, new screen.
I can do the same thing, add y's instead of b's, but just getting confused with it.
All right, so if I try to cheat and plug in 7 cubed happens to be 343, so I get 0 over 0. But the good news is that that numerator right there is b cubed minus 7 cubed. Can we factor that?
The difference of
Yeah, the difference of cubes formula. So hopefully that's burned into your mind. If not, maybe write that on the poster board, stick that on the ceiling next to the precise definition of limit. Actually, this isn't a big deal, so. Times
b squared
b squared
plus 7b
plus 7b
plus 49.
plus 49, correct. Yeah. And what if you forget that formula? What could you do instead? Synthetic division, long division, yeah, you could go either way. So there's a couple of options here. So the b minus 7, since this one in the top is connected by multiplication, I now have a number divided by itself. That's what canceling is. Number divided by itself is 1. Multiplying by 1 leaves me b squared plus 7b plus 49. Now I can safely take the limit as b goes to 7. And so I'm going to get, 7 squared plus 7 squared plus 7 squared, which is 349s, which is 147, maybe?
Okay.
Somebody help me out there.
147.
147, okay. I have a sufficient amount of coffee and a sufficient amount of rest. Everything's going okay. By the way, on the test, don't do things do things in your head like that, but always whip out a calculator to double check, right? It makes us feel powerful to do math in our head, but it's a dangerous thing to only do that on the test, right? Think it, write it, check it. That's the model. Think like stop, drop, and roll. Think, write, check. That's the way we take tests. Have we seen stuff like this before?
Vaguely for a
Yeah.
couple days.
Yeah, check this out. Suppose I let f of x equal x cubed, and I said if x equals 7, what is f prime of 7? Then this is the alternate definition of the derivative for the derivative at the point when x is 7.
Okay.
Wait. He's saying.
Right? Isn't this my f of b minus my f of 7 over b minus 7? Take the limit as b goes to 7. Yeah, so that limit, which we actually looked at one like that with squares like first week of class, was priming us for the alternate definition of the derivative. It's kind of cool. Yeah, so what we found right here, the 147, is the slope of a cubic at x equals 7 is 147, meaning the cubic is wicked steep at x equals 7. Does it make sense? Cubic's going to be wicked steep out there? Yeah, cubics rise fast, right? They just... All right, let's do another one. We have
2 minutes.
2 minutes. Oh, what could we do in 2 minutes?
I
Let's
know.
look at the... Oh, Ruby's got an idea. What is it?
Can you just go over one of the is defined, exists, like
Oh, yeah, like
22.
continuity?
can you do 22?
Sure. Excellent question. All right, so we've got this piecewise function right there. And I want to know if f of -1 is defined. And according to this up here, it's defined and it equals 2. So check. Does the limit exist? Well, the limit exists if it does the same thing on the left as on the right. So this is the left side of it. And if I plug in -1 here, what do we get? 12 minus 4 is 8.
Yes.
So I get 8 on the left side. On the right side, if I plug in -1,
You get 8.
I get 8. Does the limit exist?
Yes.
Yes. Okay. Does the function value at -1 match what the other pieces we're doing? No.
No.
Does not. So that fails. So the function is not continuous. Yeah. I need all 3 of these to be true for the function to be continuous. And there'll definitely be a question like this on the test, except I won't give you all of this right here. I'll just say, hey, is this function continuous? Why or why not? And what you would tell me is, well, it's defined at x equals -1. The limit exists at -1, but they don't match, so it's discontinuous. You would need to fill me in on these three pieces. So you need to know that continuity means these three things. So nothing you put on that poster board, hang it on your ceiling, stare at it before bed. All right, and we are just about out of time for fun with math. So tomorrow at 11 o'clock is either going to be a test day for some of you or another review day for those of you who want to do some more review. So you just need to let me know tomorrow by 11 or sooner if you want to take the test tomorrow or if you want to wait till Monday. If you take it Monday, then you have to make an arrangement with me to take it or you have to take it at a testing center. Hang on, Carter, question?
Do you have time to do one more?
I do, yes. I can hang out. Siler?
That's all we're doing tomorrow?
Tomorrow is either review or take the test, depending on your inclination.
If we don't take the test, would you be here to help us?
Yes, if you don't take the test, I'm gonna be here to review. Yeah.
Okay.
You're not gonna do it in this room while we're taking the test.
No, so we'll have two rooms. One room for people testing, one room for people reviewing. And I'll bounce back and forth between the two of them. Okay? All right. So anybody that wants